Working with Arduino. This lesson, Working with Arduino, introduces the Arduino platform, focusing on the Arduino Uno, R3. It covers the board schematic view and its various components. Practical application begins with controlling the built-in LED and then extends to using external components with the Arduino. Finally, the lesson demonstrates how to use a breadboard for prototyping circuits with the Arduino. Introduction to Arduino. Arduino is an open-source hardware and software company, project, and user community that designs, manufactures, and supports single-board microcontrollers, microcontroller kits and software for building electronic devices such as Arduino boards. Arduino boards. Arduino boards are series of microcontrollers designed for prototyping which are equipped with sets of digital and analog input-output I/O pins that may be interfaced to various expansion boards, shields, or breadboards for prototyping and other circuits. The boards feature serial communications interfaces, including Universal Serial Bus, USB, on some models, which are also used for loading programs. Arduino Language IDE. The microcontrollers can be programmed using the C and C++ programming languages, using a standard API, which is also known as the Arduino Language IDE. Arduino Uno R3 is a microcontroller board based on 8MEGA328, a single-chip microcontroller created by Atmel, designed for prototyping. It has 14 digital input-output pins, of which 6 can be used as PWM outputs, 6 analog inputs, a 16 MHz ceramic resonator, a USB connection, a power jack, an ICSB header, and a reset button. It contains everything needed to support the microcontroller. You may connect it to a computer with a USB cable or power it with an AC to DC adapter or battery. The diagram shows the functions and the arrangement of the pins on the board. You can view the Arduino Uno schematic here. Arduino Uno parts. AT-MEGA microcontroller. The brain of your Arduino Uno. USB port. Used for powering your Arduino Uno, uploading your sketches, programs, to your Arduino, and for communicating with your Arduino sketch. Power connector. This is how you power your Arduino when it's not plugged into a USB port for power. It can accept voltages between 7-12 V. Power LED indicates that your Arduino is receiving power. This light is useful for debugging. Reset button resets the AT-MEGA microcontroller. On a physical board, you might have to use it if your board isn't acting the way you expect. G&E and 5V pins. Use these pins to provide plus 5V power and 0V ground to your circuits. Digital pins. Interpret binary data, on or off, from an input component like a switch. Digital pins are used with digital read, digital write, and analog write. Analog write works only on the pins with the PWM, pulse width modulation, symbol. Analog pins interpret a range of signals from an input component. Use these pins with analog read. Pin 13 LED, the only output built into your Arduino Uno. This LED is very useful for debugging. TX and RX LEDs. These LEDs indicate communication between your Arduino and your computer. Expect them to flicker rapidly during sketch upload and while the board communicates with the computer. These lights are useful for debugging. You can view the Arduino Uno kit here containing variety of input and output components. Lighting up the Arduino built-in LED. This program uses a forever loop to repeatedly turn the built-in LED of the Arduino on and off with a delay of 1 second between each state change. When the LED is turned on, the set built-in LED to high block is executed, and when it's turned off, the set built-in LED to low block is executed. The wait 1 secs block causes the program to pause for 1 second before executing the next block. This creates a blinking effect on the LED. For this program, you just need Arduino Uno board. Observe the D13 pin on the schematic. The digital pin 13 on the Arduino Uno is by default connected to the built-in LED on the board. To lighting up the Arduino built-in LED, select Arduino microcontroller from Components panel and add it to the workspace. To develop a block program, please follow the steps outlined below. Click Code button to open Code Editor. Your Blocks Editor shows 2 containers at start. On Start, Forever, Drag Set Built-in LED to High Code Block from Output Category and drop inside Forever Container and add Wait Code Block from Control Category. Then drag Set Built-in LED to Low Code Block from Output Category and drop inside Forever Container and add Wait Code Block from Control Category. Start simulation. To create a blinking LED effect in Tinkercad, use a forever loop. Inside the loop, add a Set Built-in LED to High block to turn the LED on. Then, add a Wait 1 secs block to pause for 1 second. Next, add a Set Built-in LED to Low block to turn the LED off, followed by another Wait 1 secs block to pause for another second. This sequence of turning the LED on, waiting, turning it off, and waiting will repeat continuously, creating the blinking effect. Using Arduino with external components. You can view the electronic circuit here. For this circuit, you need Arduino Uno with following components. Hobby gear motor, NPN transistor BJT, 1 kilo ohm resistor, green LED, 250 kilo ohm potentiometer. To develop the electronic circuit, please follow the steps outlined below. Open Components Storage Box. Select and bring one Arduino microcontroller, one potentiometer, one LED, and one hobby motor to the workspace. Also bring one battery pack, one resistor, and one NPN transistor to the workspace. These are required because a motor can draw more power than a USB port is used to providing. Rotate the potentiometer, LED, NPN transistor, and hobby motor, and bring it onto the Arduino. Connect the potentiometer to the Arduino by wiring the center pin to pin A0, the right pin to 5 volt, and the left pin to GND. Connect the LED to Arduino by wiring the anode, longer leg, to pin 3 and the cathode, shorter leg, to GND. Connect the NPN transistor to Arduino by wiring the transistor's base to pin 5 using a 1K resistor. Connect the positive end of hobby motor to the transistor's emitter and the negative end to the GND on the Arduino. Connect the battery pack's positive terminal to the transistor's collector and its negative terminal to the GND on the Arduino. To develop the block program, please follow the steps outlined below. Click the Code button to open the code editor. Select Output and Control categories, respectively, and drag the following blocks in Forever Container in given order. Set Built-in LED to High. Wait 1 milliseconds. Set Built-in LED to Low. Wait 1 milliseconds. Print to Serial Monitor Hello World with new line. Set pin 3 to 0. Set pin 5 to 0. Select Input category, then drag the Read Analog pin A0 code block and above blocks. Click Start Simulation to test your code. Rotate the knob of potentiometer connected to P0 on the microbit to see the bar graph update, along with LED light based on the sensor reading. You can view the block code and equivalent C++ code here. Using Arduino with a breadboard. This program uses a forever loop to repeatedly turn the LED on breadboard through built-in LED pin of the Arduino on and off with a delay of 400 milliseconds between each state change. When the LED is turned on, the set built-in LED to High block is executed, and when it's turned off, the set built-in LED to Low block is executed. The wait 400 milliseconds block causes the program to pause for milliseconds before executing the next block. This creates a blinking effect on the LED. Following components are required. Arduino Uno R3, red LED, 220 ohm resistor, and breadboard. You can view the Arduino Uno schematic here. There's a limit to the number of components you can easily add via direct wiring to Arduino. You can also expand the capabilities of your Arduino circuits by adding a breadboard, which creates more room for prototyping. To develop an electronic circuit, please follow the steps outlined below. Pick out components from the component storage box to add to your workspace similar to the circuit shown. Create wires connecting Arduino's 5-volt pin with a red plus power rail on your breadboard, and likewise GND with a black ground rail. To change your wire colors, select the color in the inspector, or use the number keys on your keyboard to quickly switch between colors. Wire connections to 5-volt are typically red, and those connected to ground are black. Position your LEDs so the legs go to 2 different rows of the breadboard. Attach wires to any of the holes in the same row to make an electrical connection. Just like before, we want to connect the LED and resistor in series to pin 13 and ground. To develop a block program, please follow the steps outlined below. Click the Code button at the top right to open the code editor. Select Output Category in the Blocks panel, and then click and drag to Set Built-in LED to high code blocks into the coding environment. Select Control in the Blocks panel, and then click and drag 2 Wait 1 seconds code blocks into the coding environment. Now you can arrange these code blocks into the right order. Drag 1 Set Built-in LED code block into the Forever container, and then drag 1 Wait 1 seconds code block under the Set Built-in LED code block that you just placed. Repeat this pattern again with the last 2 code blocks. Changing the second drop-down in Set Built-in LED code block lets you turn the LED on and off. Change one of the Set Built-in LED code blocks to high, which is on, and the other to low, which is off. Change the Wait 1 seconds code blocks to 400 milliseconds. This adds a small delay between the LED turning on and off. Click Start Simulation to see your LED flash. You can view the block code and equivalent Arduino C code here.